Hey all, good evening. Welcome back to Polkadot India Substrate Saturday Bootcamp. And today we have our guest speaker with us to give you guys an overview on how things work in the Web3 world. Also, today marks the last session of the 3-month-long bootcamp series. We are almost at the end of this bootcamp, and congratulations to all you guys for making it so far with us. It's definitely a commendable effort, and I'm sure it's not easy to pull yourself together and sit on a Saturday afternoon to learn something. So yes, it's definitely great, and kudos to you guys. Keep it going, and good luck to all of you who's made it till here. And yes, good luck for your Web3 journey ahead. So let's begin. So Polkadex aims to create a fully decentralized platform for exchanging tokens in a peer-to-peer trustless environment, while also enabling high liquidity, lightning fast transaction speed, and advanced trading features such as high-frequency trading and trading bots. Polkadex was bootstrapped by a Web3 grant at the initial stage of the project to develop the original idea and was accepted as a member of DeFi Alliance. Polkadex believes in the power of DeFi to set people all over the world free financially. So today we have our guest expert from this amazing project with us. Please join me in welcoming Faisal Ahmed, who's a Rust developer at Polkadex. Today he'll be conducting a live workshop on introduction to testing of substrate palettes. Super excited to have you with us, Faisal, and the stage is all yours. Do we have Faisal with us?
Hey everyone. For those of you who don't know me, so my name is Faisal and I work at Polkadex as a junior Rust engineer. And I've been working, with Substrate for around 6 to 8 months. And I'm no expert, but I have a good understanding of how things are going on. And I think before that, I've been a part of a couple of open source fellowships, and I'm all open source enthusiast about it. So I think in this session, I will try to explain you about how we go about testing a substrate palette, and what are the different things you can do about it, and all possibilities with it. So one of the key aspects of it is that we normally think of unit testing as just a function where we give a XY input and then we get a Z output, and we just verify if that is the output we need. But when you think about a substrate palette basically runs inside the blockchain. So for to actually unit test that palette, we actually need something called as a state. So if you think of blockchain, it's basically a state machine. You give an input with the state and you get a new state. So basically in Substrate, we have a couple of tools that allow us to mock this state so that we can just easily, verify our logic of our extrinsic. Uh, again, I'm under the assumption that there is a good amount of knowledge transfer that has already happened with the bootcamp, because I think this is the last session. So I'm just throwing terms around. So if someone has difficulty in understanding what I'm saying, feel free to ask a question. So basically what Substrate does is it provides tool that you can easily verify your logic without having the hassle of running the entire blockchain and then submitting transaction and then seeing the output. You could do it in a mock environment, and that is what I will be talking about in this entire session, and we will be going through the entire code of it as well. So for this session, I've created an example palette where users can basically mint, create their own assets, mint for themselves, and then create an airdrop. So other participants can join that airdrop, and at the end of it, the owner can basically execute this airdrop where he can give this assets to them as part of an airdrop. So I think I'll just begin sharing my screen. Before I begin, does anyone have any questions that I can address or any concerns? So already compiled. In this session, we basically have this palette. I just named it. This is the old palette that we used to use. So because of time, I've just not renamed it. So over here, basically, we will allow users to register an asset by giving it an asset ID, asset name, asset symbol, and the amount of decimal it needs to have, and how much we want to initially mint it for that owner. And then once we do this, we allow a user to register a drop. So basically, he can say that this is my asset one, and I will allow around 10 participants, and I will give them, amount of 10 per participant. So once that is done, people can come and participate in it as join drop. So they can just use this extrinsic and put the asset ID. So I'm not using a hash or anything. It will be directly mapped to an asset ID. So they can directly press an asset one or two and join the drop. And once there are enough participants in this drop, the user can basically execute the drop. That would basically mean he will transfer the amount 10 to all the participants. So just to see this in action, before I do that, let me just go to sudo. And for folks who are new to this, so sudo basically allows me to do whatever I want. So here, what I'm trying to do is that I want to set balance for a couple of test accounts so that I can sign transactions. So I will be giving them some balance in the native currency that has been assigned for this runtime. And I will do it for 2 accounts. So that will basically load these accounts up with some native currency that I will use for signing the transactions. And now that I have done that, I will go back to the extrinsic. And now I will go to my palette. And what first thing that I'll be doing is register a new asset. So I will give this asset ID 1, and I will name it Substrate Saturday dots. And I will give it a symbol of S dot. And I will say it has double decimals. And I want to initially mint an amount of 1,000. So that would be 1,000 into 10 power 12. That would be 10 power 15. That would be 15 zeros, 12, 13, 14, 15. And now this will basically register an asset, which we will see over here. It will not only register the asset, it will register the asset, set the metadata, and then it will mint an initial amount of 1,000 assets into this account. Now that we have the asset register, now I will create a drop. So this would be same because we initially registered it to be an asset ID of 1. And I will say the maximum participant that can participate in this would be 10. And for each participant, I would give 10 units. So this would be a very small value that would go around 0.000, I think, into 10 power minus 11 or minus 10. So it's not necessarily 10 because we define the decimals to be 12. So now I will submit the transaction where I've created this drop. So once this is done, I can have other users join in. So we've registered this drop. Now I will have someone join it, and by just giving this asset ID, so I can have some other users. So we basically registered everything with body. So we will do it Eve, and now we have a user participate in this drop. So while this is all happening, so all of these extrinsic had events. So I will just show it to you here. So we started with reserving balance, and then we create new asset and we minted it, and then we all of this are part of asset registered. Then we create a drop, and then we have Eve participate in the drop. Now, what final thing that we will be doing is we will execute this drop. That would mean for Eve will be getting 10 units of that asset. And this would happen in a single shot. And if I submit transaction, you will see the Explorer as soon as it is that some assets were transferred, and this is our event, that is the drop has been claimed. And we are, for now, I've just put the owner's account ID and the asset ID. So that is basically the entire what Palette does. And you can see that verifying this entire logic is so time consuming from the browser, and doing this every time you have a new extrinsic or a new logic change is something that's not ideal for almost anyone. So I just wanted to give you a gist of how this takes place if you use an Explorer. So I think now I'll get into how we will go about mocking this entire scenario that we just did inside a test environment. So yeah, before we do that, I think I'll also go through some of the palette code. And so far, are there any questions in the chat? Uh, yeah, so I currently do not have the source of this because I am right now, I quickly created this palette in, I think this is a Substrate 19 version. So I think I will create a GitHub and I'll share it with the Polkadot India team and then they can share it to you. I think there is another question. Uh, so I think I do not know the answer to to this question, I guess. So this is not relevant to what we are talking about here. So I think I will skip this for now. Yeah. So I think if there are no more questions, then I'll go dive into the code of the palette, how the palette looks like. And yeah, so I think this is the palette. So I think folks have already gone through what a palette looks like. So I'll be really quick in explaining what the code here does. Also, I think I've kept some logic flaws here. If somebody can actually point out and tell me that this shouldn't be happening, that would be very nice. So basically, I have this config of the palette. So it is super small. I am just using this event, which is sort of boilerplate code. And I was initially going to use this module ID. So this is like the account for the palette. A lot of palettes use this for something like a custodian account. So ideally, I wanted anyone who creates a drop to transfer it to the custodian account and the custodian account sends it. But I didn't have enough time to implement this. So I think this we can ignore. And this is the entire assets palette, which you can find on Substrate. So this is responsible for minting the asset, transferring the asset, setting the metadata, and all the heavy lifting regarding the assets is done by this palette. And we are defining here. And by defining specific traits, we can access specific functions of this palette. So this is our struct of airdrop, which will have the owner, the asset ID, the max participants, and the amount. And this is just boilerplate code for creating it. And finally, we get to the extrinsics. So extrinsic are basically that, these are functions that are run on the blockchain. So basically over here, we have origin. So there can be different kind of transaction. There can be signed, unsigned, and inherent, I don't know, third type properly, but signed and unsigned transaction are most common. So here the sign, we are using a signed transaction. That would mean that anyone who calls this transaction would have to obviously pay fees. And if it would be an unsigned transaction, then you don't necessarily have to pay fees, but you do need to write logic that will make sure that nobody spams these extrinsic, because the whole point of paying fees for transaction is to avoid any spam attacks largely. And here I am basically ensuring that if somebody has already created this asset or registered, then we do not allow the user to do it. And this will create the asset, this will set the metadata, this will mint it based on the values that we give. And finally, we deposit an event saying that an asset has been registered. And we are having a storage item that keeps track of this. So this is the first extrinsic, which will register asset. The second extrinsic, just simple extrinsic that just register drop. And you can clearly see another logic flaw over here where I am not checking ensure over here. So ideally somebody else also will try to insert and it will just overwrite what was already here. So yeah, so this is not production level code. So bear with me if you find any problems. Then we have join drop where people can participate in these drops. So basically, so I'm basically having a storage item. So if people aren't familiar with Rust syntax, so I'm directly taking a storage item and I'm calling mutate on it. So when I call mutate on it, I will get the value that it was storing, the mutable reference to it inside, which is the internal vector. And then I am directly pushing into that internal vector. So by doing this, I am reducing the read writes to the storage item. And I like the syntax writing this way. And finally, if this is done, I will deposit an event saying that someone has participated in this drop. So if you see the logic, you can also see I am not ensuring that if somebody is already inside this participant list, so some user, some malicious user can basically spam and be a part of this entire, vector and get all the, drop. So yeah, I think I'm reading it. I'm thinking of attack vectors. So then leave drop will basically allow a participant to leave it. And again, this is a Rust syntax. So basically I get mutate and then I'm doing retain. So whichever, whenever the user matches here, he will be removed. So, and then I'm depositing event, which will exit drop. And again, the same thing, unregistered drop will basically remove the keys. So that way the storage map will not have these keys, and henceforth we are removing the storage item and we have this deposit event. And then finally, this is the most important part, I guess, because here we are actually moving assets. So we have the owner and we have the airdrop, and then we mutate it. So the reason why I'm using mutate over here is as soon as we transfer some funds to a participant, we don't want that participant to be a part of that vector. So that is why I'm taking this and calling pop. So pop will basically remove that item from the vector. So that way, after this function is executed, this participant will not be present in the vector, and therefore we reduce the amount of read and writes it takes to manually take, read, and then remove, and then again override. So this basically does that. And I think there is a flaw over here because we are only transferring for the user that has been popped and not the entire list of users here. So I think it should be something like while internal vector dot len is greater than 0, we run this entire set of thing inside this. So this will make sure that we execute the transfer for the entire participants. And then these are the storage items that we were using above. So these are pretty simple. So basically this will be the key and this will be the value. So we have two options here. So either it will be an option query. So when it's an option query, when you call a storage item, it could either be a sum or a null, or this could be a value query. So what value query does is that if suppose the key does not exist, then it will by default, whatever the default implementation is for this, storage struct that we're using or data type that we're using, it will fall back to that. For example, now we have vec of account ID. Now let's say for a key one, there is nothing. But when you do call it, it will, instead of giving you a none or an error, it will give you an empty vector because the default of a vector is an empty vector. So that is what a value query does. But at the same time, if you try to do one for this, when there is no airdrop or no struct inserted, it will give you a none value. So that is the difference between option query and value query. And lastly, we have a couple of events, asset register, drop created, parties. So I think these are quite obvious as we see them. So that is it with the entire palette syntax and palette code. So if there are any questions, why ensured sign for leave drop, fee for leaving the drop? Yeah. So the person who will be paying for that would be, so let me go through the code. So here, I think if somebody wants to leave the drop, so anyone who is part of the drop, they would have to pay the transaction fee to leave the drop. So as you can see over here, I am doing a participant over here. So this would be we get this from the signer. And then when we mute it, we are basically checking this function. So I think this is again Rust syntax. So what Rust does is that whenever this will return false for some value, that will not be retained inside this internal vector. So basically, this will be true for all the account IDs except for the account ID that actually stores the participant value, right? So I hope this is clear. So are there any other questions before we move on to the part where we are actually testing and seeing so that everyone's crystal clear on what we're trying to do here? Okay, so I would assume the silence means no questions. So I think I already mentioned before that how you would do unit testing for an extrinsic is completely different than how you would normally unit test a function, because these extrinsic run inside the blockchain where anything they do will result in a new state for the blockchain. So for that, we have to create a mock environment, which we have defined in this module called mock. And this is something, I think if people have already gone through the code, this is something similar to how you would define your palette inside the runtime. And what this does is that it basically defines the config for the palettes for this testing environment. So there are ideally 4 palettes that we are using, although because some of these palettes are sort of nested like inside another palette. So you also see the balances palette. So asset manager basically uses this inside its config. So we also have to define it over here. So over here we give types. So the beauty of this is that we don't have to have an SR25519 key or something for the mock environment. I can just set the account ID to be U64 and put it over here. And then, so I think I will explain you how this works. So this is one of the convenience of writing, unit test for the entire extrinsic. And the same, whatever you do in the runtime normally, it's up to you what's preferable to you. Some people will directly use SR25519 key for more, I guess, accuracy or whatever. And then we basically, again, this is all configs for the palette balances. I will not get into this and this. So this is our palette, which is what we need. So ideally, we have the event as an empty set, because also we don't care about it much. And we have the module ID that I think I already mentioned earlier, that I was initially planning on having this to be like a custodian account where users will transfer it to it. And when the execution happens, the custodian account will send it. So that way nobody runs away even after creating a drop. But yeah, I didn't get enough time to do it. And type asset manager would be assets. And this is the assets palette that we've defined over here. And this will be same, almost similar to how you would define in the runtime, but changes based on what is available to you and how you would want to do this. And I think a rule of thumb, the way whenever I write tests, is that I actually go through these individual palettes that is inside Substrate's GitHub repository, inside the frame palettes. So there you can already see these palettes have been properly tested and they already have a mock environment. So you can always read that as a reference and then build your own mock environment. And like I mentioned, that asset palette underlying uses a balance palette. So this is where it is defining it, which we have defined earlier. That is palette balance is, yeah. So we've defined it. Is that, I think, yeah. So I think it is this one. Sorry about that. This is just the balance. So this is palette balances that we are defining and which asset uses for currency. So you cannot transfer, native currency using assets palette. You have to use the balances palette, and that is why assets has that. And I think I already showed you on the Explorer how I used sudo and went to the balances palette, and I did a set balance, extrinsic to make sure that we have the native currency. And I think the last part of the mock environment is the new test ext, this function. Now, what this function essentially does is that, like I said, a blockchain is a state machine, right? So we need something that works like a state machine. That is, we give it something and it gives us a new state, and that is how we want the mock runtime to work. So this is provided by Substrate, where we can basically define the genesis. So this will basically create the genesis config. So this is very customizable. So you can directly endow some amount into some accounts when you do this. And I'm also setting a new externality. And finally, I am setting the block number to be 1. So this basically simulates, let's say I have a function that will remove all the drops, let's say after 50-60 blocks. Now if you want to test that in the actual blockchain, you would actually have to wait for 50, 60 blocks, and that is very time consuming just to verify if your storage item has been successfully removed. And so you can basically simulate that entire block numbers and do a drop and then go to block number 60 and then check if it has been cleared out properly by some hooks or something. So this is very convenient. And I think after this, I will go into how we actually write the test for this entire set of logic that I showed you for the palette. And before I do that, do we have any more questions? Something that requires clarity? Okay. Yeah. No, I haven't built the custom palettes. So these are standard palettes that I have come. Yeah, so I'm just using them. But what I am doing is that I am, um, changing the way I create the config. For example, if you were to define the standard palette inside the actual Polkadex, inside the Substrate runtime, uh, you will not get away by doing all these things. Or just so these are all defined over here. So yeah, so the difference is just in the config, not in the palette itself. So I am ideally just using the palettes that are provided by Substrate. So that is palette assets and palette balances. So yeah, I think if I do not know how to get Polkadot goodies. So yeah, if there aren't any more questions, so I think I'll go into the final part of this entire session. That would be testing. And I hope this makes sense because you will be seeing this a lot. That is, we will be getting a mock state machine that upon which we will be running our extrinsics and verifying our logic. And I think I have, is this another question? Nope, I cannot comment on that either. Yeah, so finally, I think we will get into the test folder. So before we get into it, you would see that these are a couple of exports that we do not care about. I think this is an old palette that I repurposed. So we basically take everything that's in the mock environment, and let's say so now what I will be doing is that this will give me that extra, the mock state machine. And now inside this, I will run my extrinsic that I've defined. So let's start with, registering a new asset. So let's call that. So you can see in the mock.rs. So the way I would do is that I would take this and call the extrinsic underlying it. So that would be here. I think I don't remember exact what it is. And we call it like this. And since I think I already showed you over here how in the mock environment, I set the account ID to be U64. So I don't need, a public key, private key or anything. It's just simple U64. So I think over here, you will see the first thing would be the origin, which would be assigned. And I think that would be a U64 value of 1. So this would be my account. And so what this origin is that, like I said, there are three types of, I think there are three types of transactions. One is signed, unsigned, and another one is inherent. I don't exactly remember what the third kind of transaction was, but yeah, so those are the two transactions that we can have. So for each of them, there will be an origin. So let's say this is a signed transaction. I will give the origin as it is signed, and the person who signed it is this one U64. And there are different things you can do also. Let's say you can also use root over here. So this would mean that the pseudo key guy is accessing the extrinsic, and another would be origin unsigned. Yeah, it would, for unsigned, it would be origin none, meaning that it's unsigned. So, but we define this extrinsic to, we define this extrinsic to be signed. So we have to sign it in origin, or else we would get this error called bad origin. And then I think I don't exactly remember the parameters, asset ID, asset name. asset symbol, decimal, and mint amount. Okay. So we set the asset ID. I think asset ID is a U128. So I will set as one UN28. And then we set the name. So same thing that we did inside the Polkadot Explorer, we will do over here. So it will again be Substrate Saturday dots, which we need to convert it into bytes and then convert it into a vector of bytes. Because I think we defined over there to be a vector of bytes, but we do not have the functionality of the Polkadot Explorer where I can directly enter the string and it will convert it into bytes of vector. And the symbol for this will again be again we do the same thing to it. And finally we set the decimal, how many decimal places will we allow. And finally, we define the amount that we initially want to mint. So that would be 10 power 15 because we set it to be 12 decimal places and 1 unit would be 12, 1 into 10 power 12. And so this would be 1000 into 10 power 12, which would be 10 power 15. And so now we have this. So this is our extensive that we are calling inside this mock runtime environment. Now, this ideally actually gives us a result, right? That is the dispatch result. So if you see over here, so we get this dispatch result. Now we need to also ensure that the extensive that we are calling is actually giving us an okay, right? So a result can either be an okay or it can be an error. That can be a custom error or something else. So I think before I do that, let me just run this test and see what happens. So to run this test, we don't need any fancy commands or something, just normal Rust cargo test will work it. You see it worked. Now, let's say I try to call this extrinsic outside this. I try to call it over here. So this will not work. Just I guess to show why. So it will say that we need, it is called outside the externalities provided environment. So whatever calls you're making, that requires calling the extrinsic or calling the storage item, it should always be inside this environment because like I already mentioned, so this is the mock environment that we are creating and all of this needs to be inside this. So I will put it over here. And also at the same time, in order to verify that this has been successfully, executed, I will wrap it around, I will wrap assert okay around it. So what assert okay basically does is that it's a macro that will, this is not my normal ID, so I'm struggling over here. So what assert okay does is that it basically checks if this call that we made has actually returned us an okay or not. So that is what it does. Now at the same time, so if I call this with, let's say, root, I will get an error saying bad origin. So I'll just demonstrate it to you. So this will give me an error saying that this is bad origin. Yeah, as you can see over here, you will get bad origin over here. So now that we had our asset registered, now I think we want to register our drop, right? So we will go into, I think I'll just start with assert okay so that I wrap it around it instead of doing it in the end. So I will call Polkadex and I will do register drop. Okay. And again, I think I forgot the parameters for this. So that would be asset ID, max participant, and amount. Okay. So this is again a signed transaction, right? So we again have to give it this 1 into U64. And the asset ID would be 1 into 1U128. And the max participants that we actually did in the Explorer was 10. So I'm just doing the same thing. And the amount that we offer them would be 10 units. That would be 10U128. And yeah, that's it. So now this should work right out of the back. Now, again, the good question would be like, I'm just asserting okay over here. I am asserting okay over here. Like, but how do I actually verify that this is actually working the way the logic is working, the way I want? So another convenient part of this mock environment is that I can directly query the storage item. So for example, so when I call this function, that is this extrinsic, it is going to update a storage item, right? And as we see over here, which is registered asset. So this is something that gets updated when I call this extrinsic. Now, the way I can verify that this has actually successfully run is by seeing if the storage item has been successfully updated. So what I will do is that I will just go here and I will call this, I think here there is some generic, generic syntax. Rust generics is, I would have to do something like this, registered assets. And since we are calling this inside test runtime, this is how I would do. And what I would do is that since uh, asset ID is the key, I can just do registered asset ID as contains key of asset ID. So this will return me a Boolean value based on whether it is true or false. Now, if it is false, then that would mean that this hasn't been registered, or this hasn't ran the way we wanted it to run. So let's see how this works. And this is how we can have a check for the storage to make sure that this is our intended logic that's actually running. And let's run this. I'm pretty sure this should give me an error. Yeah. So, so it's not asset ID. It could be 128. See, that would mean that we actually have this key 1U128. And if you want to be more sure that our logic is running, we can also see what is inside it. That is, we will do get U128. And I think this, since this is an option query, I am just using unraptured, and I can assert it with 1 to 64 because that is what it is storing right here. Over here, we are storing the owner, and which over here, since we are using directly 1U64, that is also a owner or user. So this should also work ideally. Yeah, and this is how we can ensure that our extrinsic actually ran and it updated the storage items. And we are going on to the next step where we are registering the drop, right? And now we write function for registering the drop. And so this should just do it, work right out of the back. And also for sanity, we will again check for storage if there is what if it has this key that we've defined. So if you look at this function registered storage item called registered drops, now all we have to is check if this has the key, which would be again be the asset ID, and we do it like this: contains key 1U128, and this should give me a true, right? Just for the sake of showing how this would fail if I give a wrong key. This should ideally give me a false, saying that there is no key like that because we still haven't done something. Now let's say if I just do the same thing again with, let's say, asset ID 2. Since we do not have any checks, this will work. It's not checking if there is an asset ID of 2. So you see this passed because it is actually updating the storage item. So we've registered. So we've registered the asset. We've checked for storage if it's been registered. We've registered the drop. Now what we do is we want people to participate in it. So now let's call the extrinsic that participates in the drop. that would be here. And we again wrap it around assert OK. And we call Polkadex IDO. I think the thing would be join drop. And if I'm not wrong, it will take sign. And let's say this will be user 2, 2u64. And the asset ID would be 1u128, because that is what we define. And this should ideally just work right out of the back. Okay. Okay, so we didn't update this. So yeah. So this user has successfully participated in the drop. Now let's again check for storage. If the intended storage has been updated, that is, we go to live.rs. Let me see what gets updated. That is drops participant. So I will just get this, and I will check the length of the vector since we are pushing into it. I will do drops test get asset ID will be 1u128. We will check its length. It should be 1, right? And this should work, I guess. Yeah, this works. That means so we have a user that's inside. So let's do this for another user. Let's say there is another user 3 that does it. So we just set it that. And so then since it gets appended to the vector, this will be 2 now, and we do it again. Yeah, so this works. So now of the things that we're trying to do in the Explorer, we've actually done it in 60 lines of code instead of manually clicking and checking events if it has been transferred. And finally, I think what we have to do is execute the drop. So for that, we will again call the function, we will wrap it around, and now we will do execute drops. And I think since I haven't put any checks, if it is the owner that's calling it, it doesn't matter who calls it. So now 1u64 and 1u128 is our drop ID. And this should work right out of the back. And so since we are clearing the vector after we do this entire execute, this should now be 0, right? So yeah, so this is 0 now. Now, when you think of this, we just wrote a function very quickly over here, and maybe I think since this took very less time compared to, for me at least, doing it in Polkadot Explorer, where I have to run the binary and then manually give everyone some balances and see if it works or not. And at the same time, let's say I just put something over here, like I put an unsure over here, saying that this. What this? I think I'll just put it over here. So let's say I just put over here and I'm sure checking if if there is already a registered drop which already has this key. So if this already has a key of this asset ID, then we should not allow someone to create a new drop with the same asset ID. And for simplicity's sake, I'll just call it asset already registered, and this will essentially give me an error if I try to register a drop with the same. So the whole thing what ensure does is that, so the first parameter, so if this is not true, then this so the entire function will give me this error as the dispatch result. So since contains key is I will have to negate this. So we want to make sure that it doesn't have the key, so that when we are registering a new drop, it's a new key. So that is what we do. And if I want to test if this is actually successfully working, all I have to do is I go here, and where is the register drop? I come here and I call, instead of, so there is one more macro that looks for, instead of looking for OK, it looks for the error variant. That is over here what we define as asset already registered. So the second parameter would be error. Yes, okay, before I do this, let me just show you what would happen if I just run it. Yeah, and it should give me an error saying that asset already registered. So this is what would happen. So if you're quickly building something, this is very easier to test out your logic rather than do it in the blockchain, running it, waiting for some blocks, and etc. etc. And all I have to do then is just do error test. This is generic, that's generic command syntax. Uh, and so if you want to check for errors, you can use this macro. As we also whenever we write unit tests, we also need to see our logic to successfully give us errors instead of panicking. And that's so this should compile now saying that. So another problem with this entire thing, if you haven't noticed, is that I cannot segregate this into different functions. So for example, I cannot have a register asset in this mock runtime environment, and I cannot do the next step over here. Now let's say if I have another function over here that does the same thing. uh, I'll just give you an idea. So if I have another function test2, and if I remove register asset, and since I've already done that, so basically this will throw me an error because I've never called that extrinsic. So I cannot do something in one function and resume it over here. So I cannot really segregate the test. It'll have to be, if I am testing for a single scenario, that is over here we are doing a scenario that is we have some user register the asset, then register the drop, participate, then execute. There's multiple things happening, but it is strategized to be in this scenario. So this is good for that. But if you want to segregate it, this would be very difficult. So try to name functions something like test, register, asset, and join, and successful, something like that. So that is one problem with this. And just to give you an example, I think I will just run it. So this again test will fail, saying assertion with this assertion will fail. Yeah, so false true, because the state doesn't get transferred, or it's not a state that is maintained by these tests, as they also run in parallel. So yeah, that's how it works. So are there any more questions? I think I will not be working on benchmarking of the palette, but assert noop is a standard macro. So I've actually, I think I don't exactly know what noop stands for. I assume it's something negative, but it is what frame that is Substrate provides. So it provides both assert noop or assert okay. I mean, in simple, it's a declarative macro, so it can just easily be something like an assert equal to, and this would also work right out of the back. But I think I would have to convert this into a type that is similar to this. And what assert noop does is that it just gives us that convenience of making sure the types are the same, what we're trying to do. Same thing with assert okay. So if I was to do this as assert equal to, all I would have to do is just do okay and do this. So this would also work. Let's give it a run. Let me remove this dummy function. So yeah, it's just more convenient to use assert okay instead of doing assert equal to, because we are doing that. So yeah, like you see, it just runs right out of the back if I just do it like this also. So yeah, and yeah, so I think I'll just convert it to assert okay now. Yeah, so that's it. And any more question? Command to run a particular test function. Yes. So the whole idea of benchmarking is that let me explain. So the whole idea why we need benchmarks is through benchmarks we can define the weights for an extrinsic. For example, as you see, so this is what you call a generic weight that I'm just randomly giving that this would take think of weights as something like 10,000 computing power or something like that. So ideally what we do with benchmarking is that we either test the worst case scenario. For example, what I would do is put every put this entire extrinsic, the testing of this entire extrinsic in the benchmark, and I put it in some machine. So and then that machine will run this entire extrinsic in that worst case scenario or multiple times to see if there are variants, and they will in turn give me a weight, and I can just use that weight over here. The whole point of using a weight is to ensure that we're not calling an extrinsic that is about to fail or something like that. So yeah, essentially, very summarize it. It's just to avoid DDoS. Let's say if you're able to correctly estimate how much weight, and weight is actually associated with the reads and writes. So let's say over here, I am doing one read over here, and this is my second read, and I have a number of reads and write over here because this is not my palette, so I cannot estimate for this. So this is where I will not be able to estimate as a developer. Like this, I can estimate for my reads, but I cannot estimate how many reads this palette will take, and that is when we absolutely need benchmarking, and estimating these weights is useless. So I think over here, so this is like an old weights file that is over here. So essentially that is what will happen. You will run it and then you will get some weight saying that it has this much reads, this much writes, and we multiply it with this amount. So yeah, ideally we should always benchmark our extrinsic, and that's a good developer practice. I hope that answers the question. And command to run a particular test function, I think that's actually fairly simple. So I actually do not have the Rust extension. So if I had the Rust analyzer install, I would just have like a button where I can run individual function. But if you do want to run a specific function, just name the function. That over here would be cargo test register, and this would just run that specific function. Uh, yes. So that's again, yeah, that also is true. So it's like uh, you would say that it's the weights are not essentially used for the developer. It's rather used for the blockchain to choose whether to reject or not depending on the weight. So I haven't really dived deep into it. It's something like how we estimate gas fees, for a contract. It's something like that. And I don't think there can be a benchmark that is poor. Let's say, like, if you say the weight is poor, then you don't really need to see the benchmark to see it, because that would ideally be because if you're doing multiple reads and writes, so that's bad code that you can read it in this 5-6 lines of code that okay, I am doing a lot of reads and writes over here, and yeah, so either you can figure it out while reading it, but uh, finding the performance through benchmarking, I think that would be more a lot of work to do. But yeah, you can use it for that as well to see the reads and writes and improve the performance on their own. But you can also, I think that you can also cherry pick it while you're reading the code. So yeah. And can't we divide tests in different files to improve readability? Yes, of course you can do that. You just have to, define. I think there are different ways where you can define the modules for your project, and we just have to add it over here, and that would also work. But yeah, that's more readability. And are there any more questions? I think I do not have anything else to talk about. So this was all, the entire, you know, what I wanted to show, that how convenient it is to write tests. And you don't really have to run the entire blockchain and, send extrinsics, see the status, see, wait for it to get rejected, something like that. So yeah, that is all there is to it. I hope everyone enjoyed it, or retained some amount of information, even though I think this is during the weekend. So yeah, I think that's it from my side. Are there any more questions? I would love to clarify any more questions. Yeah. Yes, so I will basically, as you see over here, that I actually this is an old substrate library that is 0.9.19, and I was just playing around this quite quickly in the last 2-3 hours. I came up with this, so I think I will share this with the Polkadot India team in the next 2-3 hours, and then you can play around with it, try to do whatever you want, and the good thing about Substrate is that you can do whatever you want. So I think somebody else had a question, Gunjan. I think this is a proper Substrate, runtime. So ideally, you would have to have Rust installed, and then all you have to do is cargo build release. So this will build the the binary in the wasm target. So basically, the node that we have. So there is also a difference, all right? So when I do a cargo build from here, so this will compile my entire node into a wasm target. But if I am just going to the palette and testing it, so this is basically running it in the host machine. So I've been into a lot of trouble whenever I would be like, everything is building over here, then why would that fail? And yeah, so that is a key difference that I found because of multiple bugs. So yeah, so you can just do cargo build release over here. So this will compile the entire node for you. And then since I've already done that, uh, this will just take, depending on the hardware of your machine, this may take like a minute or even up to 10 minutes, depends on the hardware, because Rust compile times are not quite fast. So since I've already compiled it, I think I'll just quit this. So once that is done, you can just go to target release node Polkadex. So since the name of this workspace is Polkadex node, and since I reuse repurpose this, so all you can do is, so if you want to run it in, there are multiple CLI flags over here. So whenever I am testing it, I normally do it in dev flag. So this way I will get all the test account that you saw over there. That's E, 4D, Alice, and all those accounts. So this is how you can run it. And I think when I'm sharing the code, I think I'll share everything, how you can run it and everything. And yeah, what's the advantage of running this over palette contract node? I think I do not know this. I think I haven't touched the palette contracts or actually written a lot of contracts in the Substrate ecosystem. So yeah, I don't think I will be able to comment on that. Yes. So yeah, I think, are there any more questions? Yeah, I would assume that the silence would mean that there are no more questions. So I think I'll stop sharing. And if there are any other questions you want to know, or just related to Substrate resources, how to get started, feel free to contact me on my social, or you can just do it over here in the chat. So if you feel there's a silly question, no worries. There's no such thing as a silly question. All questions are questions. So I think I'll stop sharing, and I think the Polkadot India team can take over. Uh, does that sound good?
Hi Kavya, I just had a question. So
Yeah,
Faisal,
definitely.
uh, what does your work involve? Like creating palettes, writing test scripts, unit test?
I
Uh,
think, yeah, a little bit of both. So I think I initially started out with testing, because I think if there are beginners here, that's the best way you can start out, because the best way to understand the logic of how everything is going on is from testing. Like since if even when you contribute to open source, the best way to contribute to any repository or understanding a code base is by first writing the test or reading how the tests are executed. So I think I started with tests, and then I started dealing with I became the CI guy because I knew GitHub Actions, and writing a CI for this entire Substrate runtime is a big pain. And I spent a week or something trying to optimize it. And just, yeah, I think I do the Substrate palettes, I write palettes, and then, we have a couple of other things that we work on. There's the order book. So the order book is like an L2 solution. So I work on that as well. So yeah, I dabble with, whenever there's an issue, if I have enough KT or enough knowledge for it, I try to work on it. So yeah, I think it's like that.
Okay, who does the design then?
So I think the design is something that, that would be a very specific question. So design would be something that, we all come to a consensus that this is what we want. And based on that design, we go forward. But, when you think of blockchain, a large part of time actually goes into designing before we write any code. So, if you look at the extensive code, it's never going to be a lot of code. It's really what you think about and then you write. So a lot of time really goes into procrastinating and designing how it will work, thinking of different attack vectors, like when I was reading my own extensive code, I was thinking like various ways someone could actually exploit it. So you have to think a lot before you actually write this code, because you are actually using assets, even though this is actually a test environment. But when you're actually putting something on the mainnet, it's people's asset that we are working with, and we need to be super sure that all these attack vectors are actually handled. So yeah, I think
No. Thank you.
yeah. And I think, how long did it take you to be proficient in Rust and Substrate from when you started? So actually, I didn't start with Substrate. So I think I started with Rust. So I've been contributing to Rust open source for over a year before I joined Polkadex. And I think when I joined Polkadex, there weren't many junior Rust positions. So I think I just jumped into whoever was giving me a job, and that's how I also learned Substrate. I felt like, since I already know Rust, this should be easy. But uh, you know, you know, as a personal opinion, I don't think Substrate and Rust are similar. So Rust is a different language, and Substrate is its own language. So there is a certain learning curve, even if you know Rust, understanding how Substrate works. And if you read the Substrate code that was written a year ago, it would be completely different than what it is now. So I've also spoken to a couple of people where, people who are initially working with Substrate, they wanted to create a DSL, basically a specific language for Substrate, but then they decided to change it to Rust. And you can see the residues from it, where you can see Substrate to be like very different than how we normally write Rust. So yeah, I mean, if you're trying to learn Rust and Substrate at the same time, I think it can get quite ugly. I mean, it can get quite difficult, but I would say, like, first learn Rust and then go into Substrate. And I would, even though people say there's a steep learning curve, I would say, like, all the resources are open source. You have the Git book for Rust. I never had to buy anything, buy a course or anything. There is all GitHub repositories. There's the official Git book for Rust. There's unofficial Git, Rust design patterns and by action. So these are really helpful. And even Substrate, I would say Substrate doesn't have as much documentation. As someone who's been working, I know that things can get fail quickly, because even Substrate keeps releasing libraries very quickly. Even just now when I was building, so this was the Substrate 19 version, and I hadn't updated for some time, and as soon as I tried updating, everything just failed. So yeah, so you need to also make sure that you are in sync with what is happening with Substrate as well. Not trying to intimidate you, but just trying to give an honest opinion that there are pros and cons with this. So is Polkadex similar to Uniswap or PancakeSwap but built on Substrate? No. So Uniswap or PancakeSwap are essentially AMMs, which is automated market making. So they basically have a liquidity pool, and then they have a certain formula that I'm not sure what that formula exactly is, but yeah, but that's how Uniswap or PancakeSwap work. But the way that Polkadex is that we have a blockchain, and then we have an L2 scaling solution that works as an order book. Order book is completely different than AMM. So in AMM, like I already mentioned, in order book, you have like how Binance works. So you know that Binance is a centralized exchange, but they have an order book wherein people can place bids and ask. And that is what we are trying to build. We are trying to build an order book, but in a decentralized system. Yeah, here's an order book style DEX. Yeah. What was the Rust in action book or repo that you? So there is this repository called Rust by example. So you can go to unofficial Rust book that is called Rust by Example. And I think there is one more book, Rust in Action, written by Tim McNamara. I'm not sure. Yeah, so that book really gives you an overview of how you can use Rust with different, system level programming, and how you think of Rust in production level systems. So that is a good book. And there is another book by John, that is I call Rust for Rustaceans, and that I think people might be already aware of it because right now it is very popular. And I would say that that book is not really for beginners, but rather for intermediate Rust programmers. I wouldn't say it's very beginnerly. And yeah, I guess that's it. So any more questions? And uh, I think one last thing would be like, the macros and substrate are a pain. So whenever you dive into it, be ready to get into this macro hell. So even if the Rust compiler is so good, if you normally write Rust programs, that it will tell you that you've missed something and do this. But when you do something wrong outside the syntax inside a macro call, the errors you're gonna get are gonna be completely different than what you are normally used to. And that will take you some time in understanding like what is this error even meaning. And I would just give that also a cautionary thing that you will get it as you work on it. So yeah, I can share these books as well. I think I will again share this with the Polkadot India team in the next 1 hour or 2 hours, and I think they will share it to you. Yeah. Yep, I will have that. Okay, so I will not endorse someone sending me the PDF in Discord. Yeah, yeah. So I think you should support the authors who wrote the book by actually buying it. So I do not want to know or hear about a PDF or something that you will share. All right, so I think that's it from my side. And I think do feel free to reach out to me on social media, because I think I've just been damned up with a lot of work as we are trying to launch our products. But I think once we have everything ready, then I will have a bit of clear time where I can also scroll social media. So great. So I think that's it from my side. And I think I just use LinkedIn, Twitter. Yeah, I think that's all I use. Just LinkedIn and Twitter. No preference really. So yeah, I think this. Yeah. So my Twitter handle is 46. I think I'm not able to send a message, I guess. So
you can share with us, Faisal, and we will share it with them.
Yeah, that sounds good. That sounds good. So yeah, that's it for me. And yeah, I'm assuming there are no more questions. Yeah, and if anybody just wants to, if someone's shy of, texting it in the chat, you can also feel free to unmute. Again, there is no such thing as silly question. Like, I am just like you. I am also exploring and no expert. So, no such thing as silly questions. So feel free. Yep.
Yeah. Cool. Thank you, Faisal, again. So guys, this marks the end of our Substrate Saturday 3-month bootcamp. I would like to take this moment and thank everyone who's behind this for putting together for this to you guys. And we also have a great news for you guys. We have Polkadex coming soon. That is our offline event in Delhi, Chennai, Mumbai, and Goa and Bangalore. So keep an eye on our channels. We'll also give you guys the information about how the placement process will be happening and a clarity on who is eligible to apply. So again, keep an eye on our community channels. Great. So thank you guys. Thank you so much. Have a great weekend.